Hey everyone, welcome back to the Foundry by Forge College, and to our explainer today, applying network selection to use cases. I'm your lead engineer today, and we're taking those abstract concepts from our network selection module and really grounding them in reality. If you've ever stared at a deploy screen, fingers sweating over the mouse, absolutely terrified you're about to make a phenomenally expensive mistake on a live network, hey, relax, take a breath. You are in exactly the right place.
All right, here's our agenda for today. We're going to do a quick blueprint recap, introduce the four axes, walk through some real-world scenarios, check out the staircase model, and finally, wrap up with some key takeaways.
Let's kick things off with Section 1, the blueprint recap, looking at mainnet versus devnet.
To put it simply, mainnet is the real world, right? Real persistent state, real economic incentives, and real operational risk. If you mess up here, you're burning actual soul. But devnet? Well, devnet is our cheap, ephemeral wind tunnel. It's a totally isolated sandbox where you can safely wreck things without crying over your wallet. You've got to keep these contrasting traits in mind because they're literally the foundation for every choice we're about to make.
Moving right along to Section 2, the four axes, mapping criteria to real needs.
So we've got four main constraints: stability tolerance, cost sensitivity, data fidelity, and persistence requirements. These four axes are going to be your ultimate filter. They dictate exactly which network environment your specific project actually demands.
First up, stability tolerance. Basically, ask yourself, can your code survive network hiccups or a random restart? If the answer is yes, devnet is absolutely your friend. Then we have cost sensitivity. If you run a high-volume test, say 1,000 times, is it going to completely bankrupt your project? Because if so, keep that test far, far away from mainnet.
Next, we're looking at data fidelity. Do your test outcomes rely on exact real-world on-chain history, like actual liquidity? If they do, you're definitely leaning toward mainnet. And finally, persistence. Does your state change need to permanently survive a reboot and, more importantly, be seen by real users? If it has to endure like that, then there's no question, that is a mainnet requirement.
Okay, so knowing the raw materials of these axes is great in theory, right? But how does this actually play out in the wild? Like, how do these four axes assemble into logical decisions when the pressure is on and a deadline is looming?
All right, Section 3, real-world scenarios. Let's look at a matrix for deployment.
Let's actually map this out. Take a look at the first scenario, a user-facing UI launch. This demands high fidelity and high persistence, so it really needs a staged mainnet canary run. Now, what about external pricing oracles? Well, they require authentic data, but they also really need stability, which makes a hybrid approach the absolute smartest move here. And historical analytics? That strictly demands real on-chain history, so for that, mainnet is literally your only valid option.
And guys, here is a crucial rule of thumb for those hybrid integrations. Testing a brand new, complex oracle directly on mainnet, that is exactly like testing a newly built airplane engine while paying passengers are sitting in the cabin. I mean, it's terrifying and it's a disaster waiting to happen. So mock your pure logic safely on devnet first. Seriously. Only after that should you perform narrow validations on mainnet.
We say this all the time across the different learning programs at Forge College, but you really need to drill this conservative threshold into your brain. Require mainnet only when more than one axis absolutely demands production realism. If you stick to this rule, I promise you, you're going to avoid jumping to mainnet way too early, and you'll save your team a ton of headaches and, well, a lot of unnecessary costs.
Next up is Section 4, the staircase model, ascending realism.
To help you swiftly reason through these choices during sprint planning, we use this model. You just ascend the staircase logically. Step 1 is the foundation, right? Local mocks. It's the absolute cheapest way to test, even if it has the lowest fidelity. Step 2 takes you up to devnet for actual runtime checks, so you're in a real network environment, but you're safely isolated. And then finally, Step 3 is mainnet. This top step should be reserved exclusively for authentic economic validations. Basically, you incrementally increase realism only when the lower steps just aren't cutting it anymore to prove correctness.
Now keep in mind, different stakeholders look at this staircase in totally different ways. Your QA engineers, they are going to absolutely love the cheap, destructive sandbox vibe of the bottom steps. They just want to break stuff. But your product managers, they're going to demand the durable, user-facing reality that you only get at the top step. So using this model is a really great way to explain to both sides exactly why a specific test has to live on a specific step.
Oh, and the secret to really mastering this staircase? It's instrumentation. You want to capture your performance metrics on devnet, and then, during your narrow canary runs on mainnet, compare those metrics against your devnet baselines. That is exactly how you catch those sneaky, invisible environmental bugs before they ever have a chance to hit production.
Finally, Section 5, Takeaways and Next Steps. Let's look at operationalizing these decisions.
We've covered a lot of ground today, so let's roll up the blueprints and quickly review the core takeaways. Here are your golden rules. Always map your requirements to the 4 axes. Default to devnet for absolutely anything destructive. Reserve mainnet strictly for authentic state. Climb that realism staircase incrementally. Seriously, do not skip steps. And finally, document your rationale. It makes future audits totally painless and keeps everyone on your team on the exact same page.
Before we wrap up, I want to leave you with a bit of a provocative thought. Before you dive into our next explainer on the network selection checklist, I want you to look at your current code and ask yourself, what is the absolute minimal validation I truly need to see pass before I escalate this deployment to mainnet? Take some time to really challenge your assumptions on that.
All right, that is a wrap for today. Thank you so much for joining this explainer. I really hope this framework gives you total confidence for your next release. Be sure to head over to forge.college to explore more Web3 resources, dive into community topics, and just keep sharpening those engineering skills. Until next time, happy building!